the elementary operation, or I should say operations on a matrix. By far this is the most important topic in the study of matrices. Why? Because all other usefulness of matrices is dependent on this only. This is the way you actually operate upon matrices. So this is, in my view, one of the most important things to study in matrices. So you should give your full attention, you should give your full focus when I am telling you. There are basically 6 types of operations in on matrices. First is interchange of row or column. Interchangeability. So interchanging, we will use the verb interchanging row or column. What is the meaning? It means, let's say we have, for example, we have this matrix, a 2 by 2 matrix for convenience, A21, A22. Okay, I write like this: row 1 is interchanged with row 2. This means our new matrix will be row 1 has been interchanged with row 2. That is, in place of row 1 we will write the row 2, and row 1 will be written at this place. That is, row 1 becomes row 2 and row 2 becomes row 1. First, what will be the effect on it? These are things that you will study later on. You should first of all understand the transformations. This is interchanging of row. So this was first. The second is interchanging column. So let's say I say column 1 has been interchanged with column 2. What is the meaning? This is column 1, this is column 2. So now this has become column 1 and this has become column 2. We have interchanged the columns. Any confusion? No? Okay. So this was the first operation, and since we have a row and a column, these are the first 2 operations. Now let's move to the second part. Second is multiplication by a scalar. Multiplication by a non-zero element. Remember this. This has to be non-zero. So how do we write? We write row 1 is now k into row 1. This is the notation. So our matrix now becomes, row 1 was this, A11, A12. This is now multiplied by k, and row 2 remains same. Okay? Or you can say the fourth one is column. Let's say column 1 is multiplied by k. So initially our matrix was this. Column 1 has been multiplied by a scalar k. So this is now k. Okay. Let's see the third one. That is, third way is multiplying. The third one is multiplying a row or column by a scalar and addition of 2 rows or columns. Let's see what is the meaning. What I say is, let the row 1 be row 1 into k plus, let's take another, m into row 2. So now what our matrix will become? This will be, our matrix was originally A11, A12, A21, A22. So we have operation on row 1 only. Row 2 remains same. This is the first thing to note. Second is k into R1 plus m into R2. See, k into this, that is KA11 plus m into second one, A21. Similarly, k into A12 plus m into A22. This is the meaning of this. Or the sixth operation is when you, the same thing you can do on a column. Let's say operation is done on column 1. Now KC1 plus MC2. So what we will have? The column 2 will remain same. That is A12, A22. And here what we get? KC1. See, KC1, that is KA11 plus MC2, M into A12, M into A12. Okay, and this becomes KA21 plus M into A22. This column remains same, A12, A22. Okay, so there are three basic operations, one on the row and another on the column. So in total we had 6 operations that we just saw. These are the basic operations on matrices, on the basis of which we do a lot of activity on the matrix, on matrices, and we are able to solve simultaneous equations. We are able to solve many mathematical problems. One of the most important uses of elementary transformation or transformations is in finding the inverse of a matrix. What are invertible matrices? Invertible matrices. Invertible matrices. See, in the number system, what we do, if we have a number A, then its inverse is 1 by A. So that A cross 1 by A is 1. Similarly, if A and B are two matrices, A and B are two matrices of order M. This means the order is not M cross N, it's M. This means these two are square matrices. So this is applicable to square matrices only. So if these two are square matrices of order M, then if AB is equal to BA, which is equal to I, that is A into B is equal to B into A, which is equal to an identity matrix of order M, then we say that B is the inverse of A, and this is how we denote it, A to the power minus 1. Okay, so if we put this in this place, this becomes A into A inverse is equal to A inverse into A, that is equal to I. Clear? So if we have two matrices such that when we multiply the two matrices, the product is an identity matrix, then, and I am talking only of square matrix, then we say that the two are inverse of each other. So this is inverse of this and this is inverse of this. Clear about inverse of a matrix? One important thing about this is, if you have if you remember, if we had two matrices, product of two matrices, and we took transpose of that product, it was B dash into A dash. Similarly, here also we have AB inverse equal to B inverse into A inverse. This will be very handy in solving some questions. The proof you can find in every book. This is very easy, simple, you can see that. In the start only I told you, we can find the inverse of a matrix by elementary transformation. How? Let's see. Let's say we have a matrix A. We can write it as I cross A because this is identity matrix. Now, if we do elementary transformation here, elementary operations on this matrix, which are restricted to only row transformations, elementary row operations only, such that finally after transformation this becomes I, then, and we are keeping this constant. So when we are doing operation on this, we are doing operation on this matrix, then what? Think of yourself. This is constant, we are not touching this matrix. We are doing operation on this and this. Then what happens? If this becomes I, this becomes A inverse, then only this is equal to I. So this is the first way. That is, if we take A equal to I into A, that is I precedes A, then we do row transformations. For what? Row transformations to make this matrix equal to I, so that this matrix transforms into A inverse. Clear? This is the first way. Second way is, we say this is equal to A cross I. Okay. Now what we do operations on this matrix to make it I, and similarly keeping this constant, we do operations on this matrix to make it A inverse. Which operations? Here when this I succeeds A, we do column transformations, column operations only. So summing up, this is second one. So summing up, if we have a matrix A and we want to know about A inverse, we have two methods. First method is we'll do row transformation. How? We'll take A equal to I into A, that is I will precede A, and we'll do row transformations so that this becomes I and this becomes A inverse. Clear? Keeping this constant. This is the first method, and the second method is we'll do column transformation. Column transformation when I succeeds this, that is this is to the right side of A. Then what we'll do? We'll do column transformation to make it I, and this will be now A inverse. Clear? Now we'll solve questions that are given in the textbook only, exercise 3.4. So we'll do some questions. Let's see how to find out the inverse. The first question is 1 minus 1, 2, 3. A is 1 minus 1, 2, 3. We have to find the inverse. Let's do the first way, that is, by row transformation. So what we do? We present it like this: A equal to IA. That is A. A is 1 minus 1, 2, 3 equal to I. I is 1, 0, 0, 1. This is 2 matrix, order 2, this is order 2 into A. Clear? So first operation we'll do, what we'll do? We have to make it like this, identity matrix. So we have to make this 0 by row only. So let's say on row 2, what we do? Row 2 minus 2 into row 1. What will happen? Row 1 remains same, 1 minus 1. This minus twice of this, so this is 0. This minus twice of this, what is this? 3 minus 2, that is 3 plus 2, 5. So this becomes 5. What about this? This is 1, 0. This minus 2 of this, that is minus 2. This minus 2 of this, same. So this is first operation. Now let's see the second one. What our goal is? Our goal is to make this matrix equal to an identity matrix of order 2. So this is 0, now we have to make this 0. How we can make this 0? See, if we do operation on row 1, where we'll add row 1 with 1 by 5 of row 2. See, 1 of 5 of this, so this remains same. 1 by 5 of this, that is plus 1. So plus 1 minus 1, 0. So what we get? This becomes 1 and this becomes 0. Clear? Multiplying R2 by 1 by 5 and adding it to row 1. And our row 2 is same. So what happens to this side? Operation is in row 1. So this plus 1 by 5 of this, that what we'll get? 1 plus 2 by 5, that is minus 2 by 5. This is what we get here. 1 minus 2 by 5. So this is 3 by 5. Okay. Then this one. This plus 1 by 5 of this, that is simply 1 by 5. And this is same. A. Okay. So what we have done till now, these two elements are 0. Only we have to make this one as 1. What we'll do, we'll apply, on row second, we'll multiply the row 2 by 1 by 5. See, R2 is now R2 into 1 by 5. So what we'll get? This is 1, 0, 0 into 1 by 5 is 0, 5 into 1 by 5 is 1. So this side, what we get? Row 1 is same, that is 3 by 5, 1 by 5, multiplying 1 by 5. So minus 2 by 5, 1 by 5. So this is our A inverse. So we get our A inverse, that is A inverse we can write as 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. Let's check it. It's always good if you have time, you should check it. Because you have A and you have found A inverse. If you multiply A into A inverse, that has to come to an identity matrix. Let's see. So 1 minus 1, 2, 3 into 3 by 5, 1 by 5 minus 2 by 5 and 1 by 5. We can take 1 by 5 out also. That's not very big thing. Okay, let it be there. So what we get? See, this into this plus this into this. So what is this? 3 by 5 minus minus plus 2 by 5. What is this? 5 by 5, that is 1. Then this one, 1 by 5 minus 1 by 5. So this is 0. See this. 2 into 3 by 5, that is 6 by 5 plus minus 6 by 5. So this is 0. This one, 2 into 1 by 5, that is 2 by 5 plus 3 by 5. See 1. So we get I. Clear? We have checked it. Okay. So this was question 1. Let's say question number 5. 2174. Our matrix is 2174. Now let's do it by column transformation. So how we'll write? We'll write A 2174 equal to this time A first and then I. So this is, now here what we'll do? We'll do column multiplication only, column operation only. So how to make this 0? Okay, first of all we'll have to make this 1. So column 1, what we do? Column 1 minus column 2. So this becomes 2 minus 1, 1, 7 minus 4, 3, and this is 1, 4. Okay, now this is A, column 1 minus 0, 1, 0 minus 1, minus 1. This is 0 and 1. Okay, this is the first operation. Now let's say second operation. What we can do on column 2? This minus 1. See, column 2 is column 2 minus column 1. What we get? 1 and 3, and this is this minus this. So 0, 0, 4 minus 3, 1. 4 minus 3 is 1. What about this side? Column 2 only. So this is 1 and minus 1. This is C2 minus C1. This minus this. This is minus 1. This minus this. That is 2. 1 minus minus 1. So 2. Okay. Now let's see the next move. We have to make this equal to 0. That is what we want. How can we make? See, we do operation on column 1. What we do? Column 1 minus 3 into column 2. This is 0, so no issue. So column 1 minus, see, this minus 3 of this. So 1, this minus 3 of this, 0, and column 2 remains same, 0, 1. So now column 1 minus 3 of column 2. So 1 minus 3 of this, minus minus plus 3, so this is 4. Clear? 1 minus 3 of this, minus 3, so this is 4. Then minus 1 into, minus 3 of this, 6, 3 C2, so 6. So what is this? This is minus 7, minus 1 and 2. So now this is identity matrix. Then undoubtedly A inverse is 4 minus 1 minus 7, 2. So we have found our inverse. Let's test it. Let's check it. See, A is 2174 and A inverse 4 minus 1 minus 7, 2. Let's multiply this into this, 8, this into this, 8 plus this into this, minus 7. So this is 1, this into this, minus 2, this into this, plus 2, 0. 7 4 ja 28, 4 into minus 28, so 0. 7 into minus 1, minus 7, 4 into 2, 8, so 1. So our answer is correct. Okay.